Good day. We'll do the math later on, but for some of the qualitative part, you have to have some understanding of Keq expressions. The idea behind Keq is you compare the products to the reactants. The products go as the numerator, and the reactants go as the denominator. The only thing you include in a Keq expression are things that can change in concentration. So that means you can worry about gases, because if you change the volume of a gas, you can change its density, which means you can change its concentration, or things that are aqueous. Things that are solid or liquid do not get included in Keq expressions. The coefficients become superscripts, what you're going to multiply by. So here we have N2O4, and there's no coefficient, so it's just N2O4. Here's our NO2, and that becomes a power of 2 because it has a coefficient of 2, so we've got to square it. This is one we'll run into a lot, the Haber process making ammonia. So there's NH3 squared with the coefficient. N2, no coefficient, so it's just the power of 1. H2, the power of 3. So we just continue like that, and you'll see they all match up. Here we have a case where we have a solid carbon, so we have the CH4, the power of 1, H2, the power of 2, and because it's a solid, its concentration won't change. It has a fixed density. It gets excluded from the Keq expression. And the same thing down here. So these are things to keep in mind as we move along through qualitative understanding. We'll come back to this when we do it quantitatively. Each Keq will have a certain value at a certain temperature. So temperature will actually change the value of Keq. And we'll run into that more when we do the math of things.